Look at something simple. A plastic bottle, a wrapper, a shopping bag. Light, cheap, convenient. That convenience built a global industry. Plastic is durable. It doesn't rot. It doesn't dissolve easily. And that's exactly the problem. When plastic enters the environment, it doesn't disappear. It breaks down, not into nothing, into smaller pieces. These fragments are called microplastics, tiny particles, often invisible but persistent. Now here's the key shift. Plastic pollution is no longer just about floating bottles in the ocean. Microplastics are found in rivers, in soil, in seafood, in drinking water, even in human blood. This wasn't speculation. It was confirmed through research by scientists such as Richard Thompson, who helped identify and define microplastics as a measurable environmental problem. His work showed that plastic doesn't vanish. It fragments and spreads. Now zoom in on impacts. Marine animals mistake plastic for food. Digestive systems clog. Toxins accumulate. On land, plastic fragments mix into soil. They alter water retention. They enter food chains. In oceans, plastic breaks into smaller particles but rarely fully degrades. Now zoom out. Plastic pollution is not only an environmental issue, it's a waste management issue, a manufacturing issue, a consumer behavior issue, a regulatory issue. Single-use plastics dominate packaging. Recycling rates remain limited in many regions. Production continues to rise. This means more plastic enters systems than leaves them. That imbalance is the crisis. Global institutions now treat plastic pollution as a systemic risk. Organizations like the United Nations, through environmental negotiations and frameworks, are working toward international agreements to reduce plastic waste, improve recycling systems, and regulate production and disposal. Their focus is not just cleanup, it's redesign. Now here's the critical point. Plastic itself is not inherently evil. It's useful in medicine, in technology, in transportation. The issue is unmanaged scale and poor end-of-life systems. Before we end, zoom out one last time. Plastic pollution teaches a simple lesson. Durability without responsibility creates accumulation. Environmental science exists to track material flows, quantify exposure, and design systems that reduce long-term risk without ignoring industrial reality. In the next episode, we'll explore the Sustainable Development Goals, where we'll see how global environmental challenges are integrated into economic and social planning frameworks. This series is part of the Learning Studio, where complex environmental issues are explained clearly, step by step, without exaggeration. This isn't about panic. This is about systems.